everyone, welcome back to the Ivy's YouTube channel. Today we are going to talk about one of the important topic in the neural network, which is called a forward propagation and a backward propagation, and how exactly work. So those who know what is a neural network, so let me simplify you. A neural network is a computational model, and it's just like a human brain. Okay, the functionality of a human brain, and it's a very key components of machine learning and the deep learning. Because why we are using, because it's find the relationship between the data, and it will make the prediction, it classify the data. So let us understand forward propagation and backward propagation with this example. So over here I have created a small neural network where I have created an input layer, hidden layer, and the output layer. Now input layer, the data goes from input layer, then the data goes from the hidden layer, and then the data goes from the output layer. Now x1, x2, x3 are my data point where I pass my data to the input layer, and that from input layer the data will go to the hidden layer. So that you will see there are something connection between the input layer and the output layer, and you will see the w1, w2, w3. Now what are those? These are called the weights. Now, what is a weight? A weight is a parameter in a neural network that determines the importance of a contribution of a particular input to the output of the neuron, and it's play a very crucial role in the neural network. Okay, because it adjusts the date and it will prediction during the training. Now, let's make more simple. A higher weight simplifies that a strong connection, and lower weight signifies as a weaker connection. Okay, now what is the hidden layer? So hidden layer will be in a neural network that lies between the input layer and the hidden output layer, and it's because there are some two operations that in hidden layer will perform, and that operations are not visible outside to the world. Now let's talk about what are the two operations. The first operation that in hidden layer will perform, which is called a weighted summation. Now what is the weighted summation? For weighted summation, each neuron will be computes a weighted sum of inputs, which is linear transformation. So over here we are just trying to identify the value of z. Okay, z is the linear combination output. Okay, w1 is your weight of each input, and x1 is the input that from previous layer. Okay, then we'll see the b are called a bias. Now let's talk about bias. What is a bias? In a neural network, bias is a linear parameter that allow to your model to shift the output of the activation function, and it helps the neural network to fit the data by providing the flexibility and ensuring the model doesn't pass through a origin point. Okay, so that's a bias, and then after doing the finding the value of z, then we will move to the second operation, which is called the activation function. Now what is the activation function in a neural net in the hidden layer? So after doing a weighted summation, so an activation function is applied in to introduce the non-linearity in the neural network. Okay, now what's the meaning of that? Basically, we are trying to identify the relationship between the input data to a output data. Okay, and if you talk about the activation function, if you want to do a regression model, you can perform MAE, MSE, or you can do a Huber loss. If you want to do a classification model, then you can do a binary cross classification, or you can do a categorical cross classification. Okay, so over here we can use a function called sigmoid. Okay, you can use a ReLU function as well. So after doing the activation function, then the data goes to the output layer, and then we will get the y hat. Y hat nothing is your output. Okay, y hat nothing is your output. So when we got the output in the hidden layer, then whole explanation is called a forward propagation. The entire explanation which I explained, which is terms of a forward proper, that is called a. Okay, now once I got a y hat, once I got a output, now what is the uses of a backpropagation? Now let's say for example in the speech recognition, if I want to pronounce my name, let's say my name is Navid, might be my model pronounce my name differently, might be pronounced Navid, or let's say Naveen, which is not accurate. So what will I do? I will pick the output and send back to the data into a neural network, which is called a forward propagation, where I'm sending my output back to my neural network, and from each neuron we will learn from their mistake. Okay, so once I send my data back to my input layer, and which is called also called a chain rule technique in the backpropagation. Okay, now what we are trying to identify, we are trying to identify by using a loss function. Okay, now what is the loss function? You can say the output of you are getting from a forward propagation. This is also called a loss function. Basically, what we are trying to identify, we are trying to identify from the output minus y hat, the actual minus predicted का whole square. That is what I need to find out. Okay, now once I perform these calculation, now as you can see, I'll send my data to back to my output, and we will use a chain rule technique to calculate the with the loss function and with the respect of each weight and the bias in the network. Now we will propagate these gradient back to the output layer in the input layer. Now how you are sending back data to your input data? For that we need to use a optimizer, and that optimizer called a gradient research. So for the gradient research, there's a whole new concept of the gradient research. Now I'm not talking about. Let's try to make more simple. Now the question is my data width will be work on the same weights? No, that weight has been adjusted. Okay, by using a gradient research technique, we were going to adjust the date, we are going to update the dates by using a gradient calculated, okay, during the backward propagation. And so that will the optimization that we are going to use in our backward propagation. So what are the formula that we're going to need in a weighted summation? So this is a formula that we're going to need, that we are going to use this formula to update the weight, and then I'll train my data back until it pronounce my proper name NAWIT. So that's the whole process of backward and the forward propagation and how exactly works. So I hope you guys like the video. If you want to know about more depth of any topic in this machine learning, drop the comment, like and subscribe, follow for more.